In this lab, we observed Newton's second law by doing the following. We observed a ball rolling across a surface at constant velocity, and were then able to use Newton's second law in the Python application to create a computational model predicting the path of the ball. We used the tracker application to gather the data for this lab. As you can see, as the ball rolls across the surface, the time and position data are recorded in the bottom right corner of the screen. You can also see that as the ball rolls across the axis, it is moving in the negative x direction. This will explain some of the results of our data later in the lab. We will use the results from this portion of the lab to help construct our computational model as we progress. Here is the code used to create the computational model for this lab. First, we inputted the mass of the object as 0.91 kilograms. However, as Newton's second law states, for constant velocity to be produced, the net force must equal 0. So, this data should prove useless as we progress through the code. Second, we inputted the initial position vector, which we collected from the data given in tracker. Second, we inputted the initial velocity vector as negative 0.0476 meters per second, which is moving in the negative x direction on the axis. We were able to collect this data by taking the average velocity between the first and second time inputs from tracker. Moving down, we can see that we set the net force vector to 0, 0, 0. This is, as stated earlier, because net force must equal 0 if we are inferring that the object is moving at constant velocity. Let's run the code. As we can see plotted, Python produced a computational model producing the predicted future position of the graph. Due to the straight line or constant slope of the line, we can see that Python did indeed predict a future velocity which is constant. Here is a plotted graph of the experimental position versus the model position. As you can see, at the beginning of the experimental data, there's a slight curvature downwards. This is likely attributed to human error in rolling the ball at constant velocity. As the ball was rolled, it is likely that it is still increasing in velocity when recorded by tracker, producing the results that we see here. Let's talk about some concluding observations. First, human error. It was difficult, if not impossible, to roll the ball in a fashion where it would be consistently at a constant velocity. Because of that, our data was not as accurate or consistent as it could have been, proving to not provide an exactly straight line as the computational model did. Secondly, video quality. The quality of my video was not excellent, which made it difficult to plot certain points on tracker, which resulted in our data not being as precise or accurate as it could have been. Thirdly, axes. My ball rolled across a negative x-axis, producing a graph that sloped down and to the right. If the ball had been rolled along the positive x-axis, all our information would have been positive instead of negative, and the slope would have graphed up and to the right. Fourthly, did the experiment work? Yes. While there were certain portions of the lab which were not as accurate or precise as it could have been, we were still able to observe Newton's second law, and that if there is no net force on an object, it is able to roll at a constant velocity. Thank you for watching.